So in this session, let's consider an example for degenerate perturbation theory, which we have discussed in the last class. So example, okay. So this is a very beautiful example. So let's consider an infinite potential well. Okay, so this is the z-axis, x, y. So you suppose you have a let's say a box here. Okay, a three-dimensional box. Clear? Now this is a cubical well. Maybe we can call it as a cubical well. So the potential is defined as V of x, y and z is 0 if what I can say, okay. So that means inside the cube you have a zero potential, and everywhere else, that means outside the well, you have a infinite potential. Clear? So this is the potential well which we have studied in undergraduate classes. Now the stationary states psi 0, we may say it has three quantum numbers nx, ny and nz, which we have derived the stationary state function as psi 0 of nx, ny, nz of x, y, z as 2 by a all raised to 3 by 2, hope you remember, sine n pi, okay, nx pi by ax sine ny pi by ay sine nz pi by az. So this is the function. So in the when we discussed about this function in the last class, some of you said that when nx is equal to 0 you have a state. No, that's wrong, because when nx is equal to 0, suppose any of these nx, ny, nz is 0, then what happens? These sine functions would become 0. That means the wave function is 0. So that cannot be there. Okay. So these nx, ny, nz are always positive integers. So what are the corresponding energy values? So first, E nx, ny, nz of 0 is pi square h cross square by 2m a square into nx square plus ny square plus nz square. Okay, that means this 0 is not the zeroth energy, but this is the unperturbed energy. Okay, clear? So this is the energy which we will be having for this what you call the infinite cubical well problem. This is the energy we will be getting it. Now on solving the Schrodinger equation you will be getting this. Okay, so now what is the minimum energy available for this? So the minimum energy will be available when nx is equal to ny is equal to nz is equal to 1. മൂന്ന് സ്റ്റേറ്റും 1 എന്ന് പറയുന്നതാണ് അതിൻ്റെ ഏറ്റവും ലോവസ്റ്റ് സ്റ്റേറ്റ് അല്ലേ? കാരണം nx, ny, nz can take only positive integer values. So 1 is the minimum. That means psi 1 1 1 psi 0 1 1 1 of x, y, z. That is the ground state, may be called ground state. Okay. So what is the ground state energy? That simply is E0 111 is when these are all 1, so we will be getting 3 pi square h cross square by 2 m s square. Clear? Now let us consider, so this is a non-degenerate state because it has only one value, okay, one state, that is this state. Okay, now let's consider what would be the next energy state. So that can be 121 or 211 or 112 because all these will be having the same energy, that is 1 square plus 2 square plus 1 square, that is 6, and again 2 square plus 1 square plus 1 square, that is also 6, and this also is 6. So all these values have nx square plus ny square plus nz square, all will be 6, and in that case all the different states, that means psi 121, psi 211, psi 112, 0, all these have the same energy, all these states have the same energy. That means these are triply degenerate state, means 3 different states but same energy. So let's call this psi 112, that's the first one. Let us say, let's call this as what I can call is psi A for the sake of simplicity. Now psi B is psi 121 and psi C is simply psi 211. Okay, and all these have the same energy 6. Okay, E10 is equal to 3 pi h cross square by m a square. 2 and 2 get cancelled, so 6 here, so that will be this. Clear? Now let's introduce a new perturbation such that h dash, this is the perturbation we will be applying. Okay, so perturbation is such that V0 would be the potential we are applying for if 0 less than x less than a by 2 and 0 less than y less than a by 2. അപ്പം a by 2ൻ്റെ എക്സിലും വൈയിലും that means here is the a by 2, here is the a by 2. ഈ രണ്ടിനും ഇടയ്ക്കായിട്ട് ഇത്രയും സ്ഥലത്ത്, ഓക്കെ, ഇത്രയും സ്ഥലത്ത് നമ്മൾ എന്ത് ചെയ്യാണ്, ഒരു പൊട്ടൻഷ്യൽ അപ്ലൈ ചെയ്യണം. ക്ലിയർ? ഈ ഒരു 4/1 ഭാഗത്ത് മാത്രം ഒരു പൊട്ടൻഷ്യൽ അപ്ലൈ ചെയ്യണം. That is clear, I hope. Okay, so that is the potential we will be applying here. We will be applying a potential, let us say, what was that, V0 or V0, yeah. So we will be applying a potential at the 1/4 of the cube. A potential V0 is being applied. So now let's do that. What will happen? So let's consider first of all what is the first order correction in ground state energy, C01. Okay, so what is the first order correction in ground state energy? Obviously we know that the ground state is not degenerate, but still we will be doing that. Let's try to do what will happen. Okay, so obviously we can find out what was the formula, psi 111 h dash psi 11. Clear? So that is a formula. So what is psi? What is the general form of psi? This is the general form of psi. So okay, so all these nx, ny, nz are 1. So pi x by a, pi y by a, pi z by a, 2 by a. Okay, so we will be taking it. So let's integrate this. So because എക്സിനെ സംബന്ധിച്ചിടത്തോളം എവിടെ വരെയാണ് പൊട്ടൻഷ്യൽ ഉള്ളത്? a/2 വരെയാണ്. That's why I will be doing this. Okay, so sine square pi by a x dx integral y യും a/2 വരെ sine square pi by a y dy then z 0 to a വരെ. z സംബന്ധിച്ചിടത്തോളം 0 to a ഫുൾ ആയിട്ടുണ്ട്. So that is sine square pi by a z dx. So now you have to find out all these three different integrals. 2 by a cube b0 integral. Okay, so let's do the integral. So let's do this first integral, 0 to a/2 sine square pi by a x dx. So I'll be doing this integral only, so that's a general form, we can do that. So this I can write as integral 0 to a/2 half minus half cos 2 pi by a x dx. Hope you remember sine square sine square x is equal to half minus half cos 2x. This is the formula. Dx. Now on integration, what I will be getting x by 2 integral 0 to a/2 minus half cos 2 pi by a, that is sine 2 pi by a x divided by 2 pi by a 0 to a/2. That is a/4 minus a/2 sine pi. Sine pi is 0. Alright, sine pi is 0. And again, put 0, that also 0. So that is a/4. Good. On proceeding the same way, this would give you right, this is correct. So what would be this? Okay. The second integral is same as this, so that also would be giving you a by, what was it, a/2 or a/4. So this is a/4, this is a/4, but this here the upper limit is a, so that by 2 will be missing, so this would be a by 2. All right. So what will be getting? So you will be getting as 2 by a all cube. Oh, am I right? All cube. Yeah. V0 into a by 4 into a by 4 into a by 2. A cube and a cube get cancelled. So 2 cube, that is 8, and 8 get cancels. So V0 by 4, that is the that's the first order correction in energy. Obviously that's the expected result. So this is a first order correction in energy. When you apply this to the this kind of a potential to the system, the first order energy correction of the ground state of the system, ground state energy of the system will be corrected by an element of V0 by 4 as the first order correction. So that's very obvious. Now we will be moving to the degenerate state. But as you know, the degenerate states are cannot be found out in this way. So for that, you need to construct the W matrix that we have constructed in the last class. So we know what is WAA. നമ്മൾ കഴിഞ്ഞ ദിവസം ചെയ്തപ്പോൾ നിങ്ങൾ ഡീജനറേറ്റ് പെർട്ടുർബേഷൻ തിയറി ചെയ്ത സമയത്ത് നമ്മൾ അസ്യൂം ചെയ്തിട്ടുണ്ടാവും, we know that Wi, the matrix element Wij is simply psi I0 H dash psi J0. Unperturbed states. These are unperturbed states. So A means here we have defined A as 112. Okay. So no, that may not be okay. So what is that? We can say integral psi 112, okay, h dash is V0, okay, V0 psi 112. Clear? This is the WAA. I will not be doing WBB and WCC because that you can do. Okay. Now that would give you 2 by A O cube V0 integral 0 to x is A by 2. A by 2, 1 ആണ് n in the value. So that is obviously what was our psi function? Psi function is 1 nx. Okay, so 2 pi by. So that means sine square pi by ax dx integral 0 to a by 2 sine square pi by a y dy integral 0 to a integral 0 to a sine square 2 pi by a y, that is 1 by 2. Okay, so that's why 2 pi by a z dz. This is what we have to integrate. I think this is the same thing we have integrated so far. No. Oh no, everything is 1. Okay, so except the last term, everything is same. So this is simply 2 by a all cube V0. So this we have done so far. So that is simply V0, a by 4 into a by 4, and what would be this? Hmm? That means sine square 2 pi by a z dz on integration. So that I think we can do that very simply, because again the same logic. Okay, so that is x by 2 integral 0 to a minus, if you check, half of, only difference is that what is that, sine 2 pi എന്നുള്ളത് എന്തായിരിക്കും, already you have a 2 again, so 4 pi by a വരും അല്ലേ, sine 4 pi by a sine 4 pi by a z divided by 4 pi by a, 0 to a. So when I put z is equal to a, this is sine 4 pi, which is again 0. When I put z is equal to 0, this is again 0. So don't worry about this. This is simply a by 2. Okay, so this is simply a by 2. So on solving this, you will be getting again v0 by what? v0 by 2. I mean v0 by 4, sorry. v0 by 4. Okay, so this is what you will get. Again, in അടുത്തതോ എ ബി ബി എന്ന് പറയുന്നത് ഡയഗണൽ എലമെൻറ്റ്സ് മാത്രം നമുക്ക് നോക്കാം. ബി ബി എന്ന് പറഞ്ഞാൽ എന്താണ്? ദാറ്റ് ഈസ് സിംപ്ലി സൈ ബി എന്തായിരുന്നു നമ്മളെടുത്തത്? 2 1 1. ഓക്കെ, സോറി, 1 2 1. So BB is 1 2 1. So 1 2 1 H dash psi 1 2 1 ആണ്. നോ പ്രോബ്ലം. ഇവിടെ രണ്ടാമത്തെ സാധനം മാത്രം ഇപ്പോഴത്തെ സെറ്റായി മാറും, ഇപ്പോഴത്തെ സെറ്റ് വൈ ആയി മാറും, അങ്ങോട്ടും ഇങ്ങോട്ടും ഇൻ്റർചേഞ്ച് ആണ്. സോ നോ പ്രോബ്ലം ടു ദ ഹോൾ റിസൾട്ട്. അഗെയിൻ ദാറ്റ് വുഡ് ബി v0 by 4. ഇനി 1 2 1ഉം 1 1 2ഉം കഴിഞ്ഞാൽ 1 എന്തായിരുന്നു 2 1 1. That also give you the same result, v0 by 4. Is it clear? So all the diagonal elements, the three diagonal elements will be simply WAA is equal to WBB is equal to WCC, which is equal to 1 by 4 v0. Clear? I think that's clear for you. Okay, now let's consider the off diagonal elements. These are somewhat a little bit interesting. So WAB, that means A was, നമുക്ക് ആ എയും ബിയും സി എപ്പോഴും കൺഫ്യൂസിങ് ആണ് അല്ലേ. സോ എ ഇസ് 1 1 2 ആൻഡ് ബി ഇസ് 1 2 1. A is 1 1 2 and B is, what was, B is 1 2 1. Okay, always remember that. So 2 by A O cube v0 integral A. Okay, A same തന്നെ 0 to A by 2 sine square A 1 1 തന്നെയാണ്, sine square pi by A x dx. അടുത്തത് B 0 to A by 2. Okay, that is something different. Sine pi by A y into sine 2 pi by A y dy. Clear? 0 to A sine 2 pi by A z sine pi by A z dz. That is what our result is. Clear? ഇവിടെ 1 2 2 1. Okay. So let's do this integral if you want. Okay, so I think the first term is very simple, that you can do. what is that first term? Simply 2 by a cube v0. First term is that, obviously you know, that is simply what, a by 4. Okay, so let's find out the second term. If you know the second term, you can find the third term because they are almost the same. Okay, so let's find out. The second term, that means integral 0 to a by 2 sine pi by a y sine 2 pi by a y dy. I mean, this is obviously 0 from നമ്മുടെ കോമൺ സെൻസ് ഉപയോഗിച്ച് വർക്ക് ചെയ്താൽ തന്നെ 0 ആണെന്ന് കണ്ടുപിടിക്കാൻ പറ്റും. എനിവേ വി വിൽ ഡു ദിസ്. ഓക്കെ, ഡോണ്ട് വറി അബൌട്ട് ഇറ്റ്. നമുക്കറിയാം സൈൻ എ സൈൻ ബി ഇസ് ഈക്വൽ ടു ഹാഫ് കോസ് എ മൈനസ് ബി മൈനസ് cos a plus b, I think. Clear? Okay. On doing this, integral 0 to a by 2, this is half, let's put out cos a minus b, cos a minus b, so that is pi, cos minus x is equal to cos x, so pi by a y minus cos 3 pi by a y dy. So on integration, this is simply integration, you will be getting what is the integral of cos a, cosine integral, is it minus sign or plus sign? Sin pi by a y divided by pi by a minus sin 3 pi by a y divided by 3 pi by a 0 to a by 2. Okay, so is it clear for you? Just a minute. So if I put this is a by 2, y is equal to a by 2, then what would be happening? Let me check. Okay, so sine, this is sine pi by 2, that is sine pi by 2 is 1. Okay, a by pi is outside, a by pi into 1 minus 0. So if I put a sine 0, this is 0 again, no problem. So all the lower limits would be 0. So this is sine pi by a, I mean a by pi minus a by 3 pi. Okay, so 3 pi by 2. Sine 3 pi by 2. 3 pi by 2 is minus 1. So this is plus. So what would be the result? This is something what you will get is, okay, so let's do this. So this is half into 4a divided by 3 pi. This is correct. 3a plus a, that's 4a. So 2a by 3 pi. That's 2a by 3 pi. Let's keep it there. Now, what about the last term? If you check the last term, again this is the same integral, almost the same integral, the order is different, but the limit is a 0 to a. Okay, the only difference is this is 0 to a. So let's put what will happen if I put a here. Okay, 0, if you put the 0, that would obviously be 0. But what will happen if I put 0? I mean a as the upper limit. So the first term would be simply sine pi a by a, that is sine pi, that is obviously 0, minus, again I put a, so that means sine 3 pi, okay, that's also 0. So obviously that would be 0. Clear? So that means the last term of this integration is 0. So something multiplied by something and again multiplied by 0, that would be 0. So whenever 2 and 1 come in z, that means here for the z limits, whenever it's 2 and 1, then it is simply 0. So what would be WBC? WBC means, oh, we haven't written the C, sorry, whatever C. C is 211. So C is 211. So let's check. What would be AC? Again, A and C also you will have 2 and 1. So AC also would be 0. So WAC is again 0. Okay. Now let's check what is WBC. BC, let's check BC. Okay, no problem for BC because it is 1 1 for the Z component. Okay, so let's check what is WBC. So that is WBC is 2 by A all cube V0 integral, let's write 0 to inf A by 2 BC 2 1. So 2 1 means sine 2 pi by ax sine pi by ax dx. Oh, what is that? 2 1 1. 2 1 1. Okay. Integral 0 to a by 2 sine square pi by a y dy integral 0 to a sine square pi by a z dz. This is what you will be getting. Okay, so when you do this integral, we already got it as 2 by a whole cube v0. This integral we already got it as 2a by 3 pi. 2a by 3 pi. The next integral we got it as, already we know, we have done it first. So these integral are simply a by 4 and a by 2. So this is it. So what is it? 8 and 8 get cancelled. A cube and a cube get cancelled. So what would be this V0? Let me check whether I am right or not. Oh, something is wrong with this equation. Some pi square and all comes. Something wrong with what I have done. 2 by a. So 2 by a all cube. So 2 by a all cube. Okay, let me check it. Something was wrong. 2. Oh, I made a mistake. Okay. B, C. C. What was C? C is 2, 1, 1 and B is 1, 2, 1. So B is 1, 2. Let's write it all together. So this is not correct. This term I've made wrong. So this term also would be something like 0 to a by 2. What is C? This is BC. So 2, 1. So that is 2, 1. BC is 2, 1. BC is 2, 1. So this is simply integral 0 to a by 2 sine 2 pi by a y sine pi by a y dy. So this is also the same as this. Okay. So this is not the result. I'm sorry. So the first result would be 2 by a whole cube v0 2a by 3 pi again 2a by 3 pi. Last term would be a by 2. Correct. Now this is fine. So that is what you will be getting is okay 8 v0 a cube will be getting cancelled. So 8 v0 into what? Again you have 4 divided by 9 into 2. So this is 2 9 pi square. So you will be getting 16 v0 by 9 pi square as the result. Okay. So when I construct, okay, I'll be taking v0 by 4 outside for the sake of simplicity because many of the terms will have v0 by 4. So the W now, our W matrix would be v0 by 4 1 0 0 okay, let me write W is equal to v0 by 4 WAA W AB WAC WBA WBB WBC WCA WCB WCC. Okay. So all the terms WAA WBB WCC, the diagonal terms we got it as v0 by 4 because v0 by 4 is the. So this is v0 by 4 1 1 1. Clear? Then AB and AC we got it as 0 and 0. AB യും AC 0 ആണെങ്കിൽ BA യും CA യും എന്തായിരിക്കും? Also 0. Okay. Now only remaining term is CA and BC and CB. That we got it as what? Okay. V0/4 പുറത്തെടുത്താൽ V0/4 പുറത്തെടുത്ത് കഴിഞ്ഞാൽ V0/4 പുറത്തെടുത്ത് കഴിഞ്ഞാൽ V0/4 കൊടുത്തു കഴിഞ്ഞാൽ 64 V0/9π² അല്ലേ? 64/9π². സോ 9π². 64/9π². This is what you will be getting. This is the equation. So this is the W matrix we will be getting. Now what is that? നമ്മൾ എങ്ങനെയാണ് കഴിഞ്ഞ ദിവസം സോൾവ് ചെയ്തത്? Now we will be finding this is a characteristic equation. So once you find out the eigenvalues of this equation, you will be getting 3 different values because this is a 3x3 matrix. So those 3 values will be give you the first order correction. So what would be this? I'll be doing, I mean, for the sake of simplicity, I'll be calling this K. Okay, so let's call this as K. So 1 0 0 0 1 K 0 K 1 എന്ന് പറയുന്ന ഒരു ഇക്വേഷൻ നമ്മൾ അതിൻ്റെ ക്യാരക്ടറിസ്റ്റിക് ഇക്വേഷൻ എടുക്കുക. ക്യാരക്ടറിസ്റ്റിക് ഇക്വേഷൻ എടുക്കാന്ന് അറിയാൻ ഓർമ്മയുണ്ടല്ലോ. 1 - λ 1 - λ ഡയഗണൽ എലമെൻറ്റ്സ് മാത്രം 1 - λ എടുക്കുക ഈക്വൽ ടു 0 ആൻഡ് ഫൈൻഡ് K. സോ ദാറ്റ് വിൽ ബി ഗെറ്റിംഗ് ലാംഡ ഇവിടെ നിങ്ങൾ തെറ്റിദ്ധരിക്കാൻ സാധ്യതയുണ്ട്. നമ്മളെ മറ്റേ ലാംഡ അല്ല കേട്ടോ, ഇവിടെ ഐഗൻ വാല്യൂ കണ്ടുപിടിക്കാൻ വേണ്ടിയിട്ടുള്ള ലാംഡയാണ്. സോ 1 - λ all cube minus K square അല്ലേ, മൈനസ് K square ഇൻറ്റു K square into 1 - λ is equal to 0. So 1 - λ into 1 - λ whole square minus K square is equal to 0. So lambda is equal to 1 and what I can say 1 - λ is equal to plus or minus K. Clear? Or lambda is equal to 1 plus K, lambda is equal to 1 minus K. Good. ഈ കെയുടെ വാല്യൂ നമുക്ക് ഇനി കണ്ടുപിടിക്കാം. കാരണം എന്താ, നമുക്കറിയാലോ എത്ര 64 ഡിവൈഡഡ് ബൈ 9π². അതിൻ്റെ വാല്യൂ 64 ഡിവൈഡ് ബൈ 9π² ആണ് അതിൻ്റെ വാല്യൂകൾ കണ്ടുപിടിക്കുക. സോ നൗ ദിസ് E1, okay, the first order correction E1 would be simply E1 0 പ്ലസ് ലാംഡ 1 ആകുമ്പോഴത്. സോ ലാംഡ 1 ആകുമ്പോഴത് സിംപ്ലി ലാംഡ, ഈ ലാംഡ നമ്മുടെ ലാംഡയാണ് കേട്ടോ, ഏത് നമ്മുടെ എക്സ്പാൻഷനിലെ ലാംഡയാണ്, ഈ ലാംഡ അല്ല. ഓക്കെ, ലാംഡ V0/4. ദെൻ അടുത്തത് E1 0 പ്ലസ് ലാംഡ ഇൻറ്റു 1 പ്ലസ് 9/4 എത്രയായിരുന്നു, 64/9π². 64/9π² V0/4. അടുത്തത് E1 0 പ്ലസ് ലാംഡ ഇൻറ്റു 1 മൈനസ് 64/9π² V0/4. So these are the 3 correction values corresponding to this perturbation. Okay, so that's clear. Hope you got it. So it's a little bit lengthy example, but anyway this is a very interesting example. Try to do as. Okay, so what here is on the application of perturbation, what will happen actually എന്താ സംഭവിക്കുന്നത്, നമുക്ക് ഇവിടെ E10 എന്ന് പറയുന്ന ഒരു എനർജി ഉണ്ടായിരുന്നു. ഓക്കെ, ഗ്രൗണ്ട് സ്റ്റേറ്റ് ഇല്ല, ഗ്രൗണ്ട് സ്റ്റേറ്റ് എന്താണ് E11 എന്ന് പറയുന്നത്, അടുത്ത 3 സ്റ്റേറ്റുകൾ ഉണ്ടായിരുന്നു. അപ്പോൾ ഓൺ പെർട്ടുർബേഷൻ, ഓൺ അപ്ലൈയിങ് ദ പെർട്ടുർബേഷൻ, ദിസ് വുഡ് ബിക്കംസ് 3. I mean ഇവിടെ 3 സ്റ്റേറ്റും എന്തായിരുന്നു, 3 സ്റ്റേറ്റുകൾക്ക് ഒരേ എനർജി ആയിരുന്നു. ഓൺ അപ്ലൈയിങ് ദ പെർട്ടുർബേഷൻ വാട്ട് വിൽ ഹാപ്പൻ, ദേ സ്പ്ലിറ്റ് ഇൻ ടു 3 ഡിഫറെൻറ്റ് ലെവൽസ്. അതായത് പെർട്ടുർബേഷൻ V0/2 എന്ന് പറയുന്ന V0 എന്ന് പറയുന്ന പൊട്ടൻഷ്യൽ നമ്മൾ ആ ക്യൂബിൻ്റെ 4/1 സ്ഥലത്ത് മാത്രം അപ്ലൈ ചെയ്യുന്നതിന് മുൻപ് 211ഉം 112ഉം 121ഉം ഒരേ എനർജിയിൽ ഇവിടെ ഇങ്ങനെ നിൽക്കുമായിരുന്നു. ഈ പെർട്ടുർബേഷൻ അപ്ലൈ ചെയ്യുന്നതോടുകൂടി എന്താവും, ഇവർ 3 പേരും കൂടി ലാംഡയുടെ വാല്യൂ, ലാംഡ 0 ആകുമ്പോൾ ഇവിടെ, ലാംഡ 1 ആകുമ്പോൾ ഇവിടെ, 3 പേരും എന്തായി, സ്പ്ലിറ്റായി വെവ്വേറെ എനർജി ആവും. ആൻഡ് ദാറ്റ് 3 energies are shown here. Clear? This is what you will be getting. So that's all for the time. It's a lengthy example, but anyway, it's an interesting example. Try to do it yourself. Okay, thank you.